So a common question students ask is, why split everything up into separate classes? Why use inheritance to split everything up into multiple classes? Why not have everything as one big class of everything including the kitchen sink? So why not pile everything into one class? There's a lot of very good reasons why we don't do that. And we will answer these questions by looking at some examples, some example classes, and illustrate and explain everything using UML class diagrams. So we won't do any Java code to keep things as simple as possible. Don't want people distracted by the Java. We're going to focus just on the concepts. Okay? And once you understand the concepts, the code's easy. So let's say that we've been asked to design an employee class. And there it is there. That's our UML class diagram. So we've got an employee, we've got an ID for their identifier, name, date of birth, address, city, state, postcode, and their salary. And we've got a default constructor which takes no parameters. It just initializes everything to 0 or space or blank. And a parameterized constructor which takes in the parameters so we can initialize everything. Then we've got our accessor methods, the get ID, the get name, the get date of birth. Our mutator methods, the set ID, set name, set date of birth, and so on. A toString method, and any other strings we might need. Okay, for example, calculate salary increases or something like that. Okay, so that's our diagram there for employee. And that looks quite reasonable. Okay, that's something that we could go ahead and build right now. Okay, but what happens... okay, before we move on, every method that set or changed class data would need to make sure the validation rules for the data were enforced. So all of the set methods, the constructors, everything else would have to make sure that the validation rules for the data are enforced. For example, you might have a business rule that names cannot be blank, address cannot be blank, postcode must be a valid postcode, the postcode must be the right postcode for the city or town. Okay, so all of those are very reasonable validation rules, and so on. There could be many, many validation rules. Okay, often there's many rules just for one piece of data. Okay, so we write the code for the employee class, and everything's good. Okay, and then when we are finished, we're asked to implement another class for customers. Okay, so we're going to now write the code for another class called customers. And that's the UML class diagram from our class. So we've got an ID, a name, a date of birth, address, city, state, postcode. But the customers are slightly different than the employees. We're keeping track of the number of orders they've placed and the total purchase value for those orders. Okay, we've got suitable constructors again, a default constructor and a parameterized constructor. And we've got the various mutator methods and accessor methods and a toString and any other methods we might need. Okay, so they're all part of that class. Once again, every method that sets or changed class data would need to make sure the validation rules for the data were enforced. For example, name cannot be blank, address cannot be blank, postcode must be a valid postcode, postcode must be the right postcode for the city or town, and so on. Does it look familiar? It should do. So a lot or most or even all of that validation is exactly the same as for the employee class. But because we've implemented these classes as separate classes, there's no inheritance hierarchy, there's no link between them. We have to write all of the code to do all this validation again. Now we'll probably copy and paste it and change it, but we have to have all of the code again in a separate place. Okay, that's not good. There's lots of duplication, there's lots of reinventing the wheel, and neither of those things are good in a project. Worse still, if the validation rule for any of the data changed, we would need to make sure we would need to make the same change to the code in two classes. Okay, so we're changing, if one change could result in multiple changes to the code in multiple files. If we wanted to add these rules, the name must be at least 3 characters long, names must contain only alphabetical characters, and so on. There's many other rules we could add. We would have to write the code to do this and add it to 2 separate classes or 2 separate files. Okay, that's not good. And what if we were then asked to develop classes for suppliers, students, consultants, potential sales contacts, contacts in other companies, investors, shareholders, and many other things? Okay, are we going to then turn around and duplicate all that code again for each of those classes? And if one of the rules change, one of the validation rules changes, you have to change it in dozens of files. It's not a good design, is it? So some questions. Who wants to write the same code 5, 10 or 100 times? Hands up. I can't think of anybody that would want to do that, and if you did want to do that, you'd be crazy. Who wants to make identical changes to the same code in 5, 10 or 100 separate class files when a validation rule changes or some other processing changes? Nobody would want to do that. And then test all those changes in all of the classes. You'd be there forever. Okay, you'd be there for weeks. Who wants to reinvent the wheel over and over and over again? Anybody? Okay, so these are all answers, questions where you'd answer no to all of them. If we followed through the above design and made everything a self-contained class with no inheritance, no linkages between them, then we would be creating a maintenance nightmare. And if you do that, good luck. I wouldn't want to be part of it. And don't laugh there, some programmers have fallen into that trap, and it's certainly no fun at all. It's no fun for the programmer who does it, and it's no fun for the poor people that might come along after them and inherit their work and have to maintain it. So the solution, is there a solution? And thankfully there is, and it's one we've been talking about for the last couple of weeks, and that's inheritance. We put the common data and behaviour, the methods, in a superclass called person, for example, and then we build an inheritance hierarchy to focus each subclass on a particular type of person or data. For example, we'd have a customer class. So here's our person class. We've got all of the common data up here. Name, date of birth, address, city, state, postcode. There might be other data as well. That's just the data I've used for this example. And then we've got our constructors, our accessor methods, our mutator methods, the toString, and any other methods we might need that are applicable to all of the data of type person. Okay. And then we'd have an employee class that extends person, and that would have a salary data item, and then suitable constructors, accessor methods, mutator methods, and toString, and so on, any other methods we might need. And then we'd have a customers class that extends person, and that would have the customer data, number of orders, the total purchase value, suitable constructors, the accessor method, the mutator method, anything else we might need, the toString method, and so on. Okay, so that's what we end up with. Employee, customer, and any other people we might be thinking of, and they are inherited back to the person class or extends the person class. Okay, we might have different types of customers, we can add that in. We might have different types of employees, we can easily add that into our hierarchy. Okay, we can add other sorts of people in, or other types of data that are related to a person in as well. Okay, it's all very easy to extend and expand and build. So what are the benefits of that? It's a nice clean design. We've got small self-contained classes which are easy to understand, maintain, test and debug. Very big points. It's very reusable for future projects. There's no duplication of code or functionality. It saves lots of time and effort in the long run. It might be a little bit harder to set up initially, but once you've done it, gee, it's easy to extend and expand. Okay, so it saves lots of time and effort in the long run. Enormous amounts. New or changed functional of validation rules, if we've got those, we just change the code in one place or a minimal number of places, and then recompile, test, and we're done. If a special version of a method is needed in a subclass, we can always use our good old friend override that we've looked at in previous weeks. Okay, so lots of benefits there, lots of very important benefits. What are the disadvantages of doing it? Well, you've got a little bit more work to set it up. Not a big deal at all when you think about those benefits. The benefits way outweigh the negatives. Okay, so split your code up into multiple files, into multiple classes. Split your data up into multiple classes. That's a good thing. Get comfortable with it, get your practice, and it'll soon become second nature. So conclusion, think about the data first. If you can get the data right, the rest of the development will be much easier. That's a good rule of thumb for the future, a good rule for the future. Okay, think about the data first. If you can't get the data right, you can't get anything right. Okay, so focus on the data. Don't just jump straight into the coding. Always keep an eye out for common behavior, common data. Always think about future reusability. Always look at your code and ask, how can I do this better? Once you get some practice and start splitting things up into classes and following the above advice, this will all become second nature. You'll do it automatically as you're developing code. Okay? Hope that helps. Thank you.